Good learners, welcome back to our chemistry class. Today is going to be the continuation and the end of our first law of electrolysis, Faraday's first law of electrolysis. Before we proceed on this topic, if you are a new member on this channel, kindly look at the description below to watch the previous videos so that you can join us in order to understand properly. And don't forget to subscribe, like, and share my channel. Let's proceed. Example 1. A current of 4.0 amperes was passed through copper 2 tetraozo sulfate 6 solution for 1 hour. Calculate the quantity of electricity passed. B. Amount in moles of copper deposited at the cathode. Now, let's look at the question once again. A current of 4.0 ampere, that is our current I, 4.0 ampere, was passed through a copper 2 sulfate solution for 1 hour. Our time T equals to 1 hour. We have to change this 1 hour to seconds. 1 multiplied by 60 times 60, we have 3,600 seconds. From here, we are told to calculate question A, the quantity of electricity passed. We know that quantity Q is equal to IT, and our I is 4.0 multiplied by 3,600. So we have 14,400 coulomb. So this is the quantity of electricity that is passed through the electrolyte copper 2 sulfate. This is question A. Question B. Calculate the amount in moles of copper deposited at the cathode. We know very well that copper is having 2 charge plus 2 electrons. We are going to be deposited this copper solid. From here, 2 Faradays of copper ion will give us 1 mole of copper. And this 1 mole of copper is equivalent to the molar mass, which is 63.5 grams. 63.5 grams. But we were asked to find the amount in moles. From here, 2 Faradays of copper ion is depositing this 1 mole. 1 mole of copper metal. And 2 Faraday means 2 times 96500 coulomb of copper 2 plus to give us 1 mole of copper. And when we look at this quantity of electricity that we got here, we got 14,400 coulomb. So this coulomb will be under this coulomb. 14,400 coulomb of this copper 2 plus will give us how much? Let's call it Y. Because we are asked to find the amount in moles and not in mass. That's the reason why I'm not using this. Cross multiply. This multiply this. 2 multiplied by 96500 multiplied by Y is equals to 14,400 multiplied by 1. To get my Y, I have to divide both sides by this. So Y equals to 14,400 times 1 divided by 2 multiplied by 96500. So what do we have? We have 0.075. That is mole. So which means that 14,400 coulomb is going to produce 0.075 mole of copper. Example 2. A current of 0.20 ampere flowed through silver 1095 solution during an electrolytic process that lasted for 30 minutes. Calculate the mass of silver deposited. Fine. Here, we have a current of 0.2 I, 0.20 amperes, flow through silver triosonitrify solution during an electrolysis process that lasted for 30 minutes. Our time is 30 minutes. We have to change these minutes to seconds. 30 multiplied by 60. That is 1,800 seconds. Before proceeding, we have to get the value of our Q here. That is Q is equals to IT. So if we've gotten the value of our Q to be IT, then we substitute. Our I is 0.20 multiplied by our time, 1,800 seconds. Now let us multiply this. We have 360. Unit of Q is coulomb. Now, calculate the mass of silver deposited. Don't forget, we're dealing with silver 1095. Silver is Ag plus, accepting 1 electrons to give us Ag. So 1 Faraday here will give us 1 mole. But we are dealing with mass now. So this 1 mole equals to the molar mass, which is 108 grams. So from here, 1 Faradays of silver ion is depositing 108 grams of silver solid. So 1 Faraday means 96500 coulomb of silver ion depositing 108 grams of silver. Fine. This Q that we got 360 coulomb of silver ion will produce how much? Let's call it X, unknown. We cross multiply here. 96500 multiplied by X is equal to 360 multiplied by 108. I need my X. I have to divide both sides by 96500. My S equals to 360 multiplied by 108 divided by 96500. Let's press our calculator to look at what we're going to get. We have 0.4, and what is what? Grams. So the mass that we're going to get from this 360 coulomb is 0.4 grams. Example 3. 0.50 grams of a divalent metal was deposited when a current of 0.45 ampere was passed through a solution of its salt for 30 minutes. Using the appropriate electrodes, calculate the relative atomic mass of the metal. 1 Faraday equals to 96500 coulomb per mole. Now, the first thing we have to look at is divalent metal. When we say a metal is divalent, it means a metal that possesses 2 charge. Trivalent, it possesses 3 charge. Monovalent, just +1. Now, we now said that 0.50 gram of a divalent metal was deposited when a current of 0.45 ampere, a current, our I, 0.45 amperes, was passed through a solution of the salt for 30 minutes. Our time equals to 30 minutes. Converting this minute to seconds, 30 multiplied by 60, we are having 1,800 seconds. From here, we have to get the value of our Q. Q is equal to IT. Our I is 0.45 multiplied by 1,800. Let us multiply. We have 810 coulomb. Let us now read this question. 0.50 grams of a divalent metal was deposited when a current. So instead of mentioning 0.45 ampere and measuring 30 minutes, we just say that 0.50 grams of a divalent metal was deposited when a current of 810 coulomb was passed through it. So the quantity of electricity that was passed through it now is 810 for a divalent metal, which means that 0.50 gram is going to be equal to 810 grams. Now, calculate the relative atomic mass of the metal. Now, don't forget that it's a divalent metal. Let's just assume we have M2 plus as a divalent metal, accepting 2 electrons to give us M, which is the metal. This is our aqueous. Here, 2 Faraday of this one is given 1 mole of this. Is given 1 mole. So from here, we can interpret this one as 0.50 grams, 0.50 grams of this divalent is producing this quantity of electricity, which is 810 coulomb, 810 coulomb of electricity. Are we there? Now calculate the relative atomic mass of the metal. So which means that what is this mass? Mass will be under mass. How many mass of M2 plus we deposit 2 Faradays? Don't forget 2 Faradays given our 1 mole, and 1 mole is equal to unknown mass in grams. It's equal to unknown mass. The unknown mass is this, Y equals to 2 Faradays. And we know that cross multiply from here, we are going to have this times this, 810 multiplied by Y is equals to 0.50 grams times 2 Faradays. Y will equals to 0.50 times 2 times F divided by 810. That is 0.50 multiplied by 2 multiplied by our Faraday is 96500 divided by 810. So when we multiply, what do we have? So we have 119 grams. But we are told to find the relative atomic mass of the metal. So from here, the relative atomic mass equals to 119. So without unit, because we're talking about relative atomic mass, it has no unit. So that is it. Example 4. 1,400 centimeter cube of oxygen was liberated at STP during an electrolytic process lasting 4 hours. Calculate the amount of current that has passed through the electrolyte. Now this is in terms of gas, molar gas volume, relationship of that electricity to the gas volume. Now we're talking about oxygen, a gas. 1,400 centimeter cube of oxygen was liberated at STP during an electrolytic process lasting for 4 hours. Our time T equals to 4 hours. Changing it to seconds, 4 multiplied by 60 times 60. We have 14,400 seconds. Our current I is unknown. Recall that Q is equal to IT. Our time is 14,400 I. The unit is coulomb. That is Q equals to coulomb. And I've told you from my previous class, when we started this class, that oxygen gas is gotten from OH group, which gives us H2O plus oxygen plus electron. This is 4, this is 4, this is 2. So which means 4 Faradays. 4 Faradays of electricity requires 1 mole of oxygen. And 1 mole of oxygen is equivalent to 22,400 centimeter cube or 22.4 decimeter cube. So from here, 4 Faradays of oxygen gas will give us 1 mole. And this 1 mole equals to 22,400 centimeter cube. So we want to use mixture of this one. So 4 Faraday is 4 times 96500 coulomb of oxygen, giving us 22,400 centimeter cube. Fine. Then this is Coulomb. Likewise, this one is Coulomb. 14,400 I Coulomb of this electricity will give us watts. That is 1,400 centimeter cube. So we are told that 1,400 centimeter cube of oxygen was liberated at STP during an electrolysis process lasting 4 hours. So which means this one is being produced from this time, and this time is located here. So which means that 1,400 centimeter cube will be equating to 14,400 I. Cross multiply. This times this 22400 times 14400 I is equals to 4 multiplied by 96500 times 1,400. I need my I. My I will now equals to 4 times 96500 multiplied by 1,400 divided by 22,400 times 14,400. And if you want to press this, after you press this numerator, 4 times 96500 times 1,400, you divide by 22,400, press equals to, then divide again by 14,400, press equals to get your final answer. Because if you multiply it, you're going to get a wrong answer, higher than normal. But or you multiply the numerator, then divide by, open your brackets, put this one in the bracket, close the bracket, and press is equals to. So what do we have? So here we have 1.68 amperes. So this is how to go about Faraday's first law of electrolysis. If you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent contents. And don't forget to share, like, so that other members can also benefit from here. I remain Latif Ismaila Akombi, your mathematics and chemistry tutor. Until we meet on the Faraday's second law of electrolysis, stay cool and enjoy the class.